something like 198.136.56.2. That's the example given here, right? So it's a 4 decimal numbers separated by dots, something like this, and each and every part will be having a 8 bits, right? So 4 into 8, totally 32 bit will be there. So 8 bit can have a maximum value of 255 in the decimal equivalent. So the maximum possible number is 255.255.255.255, right? But of course the MSB will be always 0, which we are going to see, of course. And each decimal point, each decimal number is a decimal value of an octet, that is the 8 bits, right? So I think this is an example for a header file, right? I think already we have discussed this is a simple example for a header file of a BMP, right? What is a BMP file? Already you might be knowing it. It's a basic image processing file, image file, right? Some a.bmp, something like that. So the BMP will be having 56 bits, 56 bytes of data, right? So here you can see the signature, that is the first 2 characters should be BM. That indicates it's a BMP file. The next thing is, what is the file size in the bytes? What is the file size? Depending upon the dimensions of the image, the file size will of course vary. Then the next 4 bytes are unused. I think you can just go through this. The next thing is file offset to raster data. Of course, this is not necessary. That we will understand what is the header. And some other thing is, what is the bitmap width is there, bitmap height is there, and bits per pixel. So what is the resolution of the image, right? Say for example, 1 means it's a monocolor, either it can be black or white. 4 means we will be having 4 bits, so we can have a 0 0 0 0 to 1 1 1 1. So 16 levels are actually possible, right? Similarly, 8 bits are there, 16 bit are there, 24 bit RGB is also there. Again, it's a black and white or RGB, color is there. And type of compression is used, right? RLE stands for run length encoding. So what type of compression is used for getting the data, right? So these are all the few informations that are useful to specify what type of file it is. So this is one simple example of a BMP header. Of course, this is just for your information. And here we can see the data packet, right, from R to the transport layer. Of course, we have seen this already. So here actually what happens, the data is given 0 to 3 gives the IP version, right? Already we have seen this is actually the IP header. You can see 1 by 1 field, right? So 0 to 3 is the IP version. Either it can be 0100 or 0101, either version 4 or version 6. And the service type and precedence, so that indicates that is 4 to 7 and 8 to 15, right? The total data. What about the priority given to the data, and all those things will be there. From 16 to 31, it denotes the length of the IP packet, right? What is the size of the data available there? And 32 to 46 gives the first byte sequence number. Say for example, I want to transmit some 1000 bytes. Now my each packet can have only 100 bytes. So in that case, what happens? I have to split my 1000 packets into 100 bits packets, right? 100 bytes packet we can say. And we have to give the sequence, because the first 1 to 100, then 101 to 200, then 201 to 300, something like that. We need to give a sequence number. So this 32 to 46 gives the sequence number of that. And there are some flags are used, 47 to 50, we are going to see that. And there is a fragment offset. Say for example, each and every packet will be having something around 100 bits. But what happens, I have 546 bits in total. So in that case, what happens, 500 bits will be packed into 5 packets, and the remaining 46 bits will be padded up with the remaining thing. So that is actually called as a fragment. So in the 6th packet, only the first 53 bits, supposing if that is the data size, that has to be processed. So that is actually called as the fragment offset. Then we are going to have a time to live, that is from 64 to 71. The time to live denotes what is the time the data can live. Say for example, the data cannot be there for entire period, right? So either we have to specify the time in terms of seconds or something like that, or we can also specify the number of hops it can withstand. Say for example, I am transmitting data from here to some America, right? So in between, I will say that my system, my data should be there for 10,000 hops. In that case, Whenever it passes through a computer, right, or a router, we can say the amount of hops will be reduced from 10,000 to 1 by 1, it will be reduced. When the data reaches the destination before the 10,000 hops, no problem, the data will be processed. Supposing if the data is not reaching by the time, the data will be automatically get deleted, right? If the hop number gets 0, the data will be automatically deleted. So these two informations are provided in the time to live. And what type of protocol, say for example ICMP protocol is also there, so which type of protocol is used there, and what is the checksum. This is actually useful for finding out whether it's a error correction or error detection purpose. We are going to have a checksum. And bits from 96 to 127 will be having a source address, the IP address of the source, and 128 to 159 will be giving the IP address of the destination. And 162, the next thing is going to be optional data, and then we will be having the exact data. So this is actually the header structure. The header structure of IP will be having 5 words, right? From 0 to 31, 1 word, 32 to 63, 64 to 95, 96 to 127, 128 to 159. So these 5 words should be available in the IP address. And the next thing, 160 and all will be optional, right? So what about the IP header? For already we have discussed, we will just go through once again. The IP header first consists of 5 words. That's what we said. The header extends by using the option. So the header can be extended by using the word. Some optional words are also possible, right? And the data stack to the network layer has a maximum of, what is the total size of words? It should be 2 power 14 minus n words should be available here. And the maximum packet size should be 2 power 14. And of course we have seen already all these things. B16 to B31 will be the length, B4 to B15 will be the type and the precedence, B3 to B0 will be IP versions, B51 to B63 will be the fragment offset, and 47 to B50 will be flags, 32 to 46 will be the first byte sequence number in the packet. And this is actually the flag available. So the flag we can have 3 bits are there. The first bit should be always 0, right? It must be 0. And the bit 1 shows either I can fragment the data or cannot be fragmented. So bit 1 says no, don't fragment the data, it has to be passed in a single packet. And bit 2 can be more fragments can be done. Right, so this is actually the header structure of a UDP protocol, right? Already we have seen IP protocol. Now we are getting into the UDP protocol. When we are getting into the UDP protocol, you need 2 things. One is actually the source IP address. Already in the TCP protocol, we have seen the data is from which application it has coming, right? That we have to see. But in the UDP protocol, we did only 2 things. What is the source IP address? What is the destination IP address? And then what is the source port number and destination port number? So this is also needed. And the checksum should be there. What is the length of the packet and what is the actual data? So this is the UDP protocol header structure. And already we have seen what is a 4-bit 4 decimal numbers, right? The IP versions 4. And as I said, 00002 255.255.255.255 is actually possible. 3 separate fields with a decimal number each for each set of 8 bits for easier use. And there is a subnet. Say inside a network we can have the subnet address, right? So subnet address is also similar to your IP address. So a subnet is a subnetwork consisting of number of hosts or nodes or computers that is available within a group, we can say.